Hello. Hello, Charan. Minal, how are you?
Fine, sir.
Right. So let's wait for a minute and then we will start. Okay. So we were discussing about the circular motion. Circular motion. There are two type of acceleration in the circular motion. So we were discussing about that one. Okay. आप बैठिए उधर ठीक है
नहीं दिखता है मुझे इसे
Okay. There back. Okay. Let's start now. So circular motion we discussed. There are two type of circular motion. Okay, na. So, what are those two type of circular motion? The uniform circular motion and the non-uniform circular motion, isn't it? So, what is the difference between uniform and non-uniform circular motion? Tell me. In the uniform circular motion, what will happen? There are going to be no tangential acceleration. Okay, speed will be constant. So, tangential acceleration will be what? Zero. And centripetal acceleration, that will be always there. Okay, so whether a circular motion is a uniform or a non-uniform, centripetal acceleration is always going to be acting on the particle. Okay, if the particle is doing the circular motion. Okay, so uniform circular motion, what happens? Net acceleration will be just the centripetal acceleration, isn't it? But in non-uniform circular motion, what will be the condition of non-uniform circular motion? Tell me, what is the condition for non-uniform circular motion? All of you joined? Today, Lokesh has not yet joined.
अभी इसे
Please. Okay, chaliye, let's continue. So, non-uniform circular motion. So, in a non-uniform circular motion, what will happen? The speed will keep on changing. Okay. Okay, na? In a uniform circular motion, speed was constant. And in a non-uniform circular motion, what will happen? Speed will be also variable. That means what? Speed will keep on changing. Okay. So here you can say that speed is going to be what? The variable. So if speed is variable, that means what? In a non-uniform circular motion, we are going to have both kind of acceleration. Tangential acceleration, non-zero. Centripetal acceleration, that is also non-zero. Understood? So in a non-uniform circular motion, we will have two type of acceleration, tangential acceleration and the centripetal acceleration. Both will be there. Okay. So if someone asks you to calculate what is the net acceleration, so what will be the net acceleration of a particle doing non-uniform circular motion? So in a non-uniform circular motion, the net acceleration will be what? Let's say the particle is moving like this. This is the tangential velocity of the particle. So it will have one acceleration. Let's call it A tangential. And there will be another acceleration. Let's call it A centripetal. So net acceleration will be what? And tangential and centripetal, are they perpendicular of each other? So if they are perpendicular to each other, so resultant will come A tangential square plus A centripetal square. Understood? So resultant of these two will be called as the net acceleration. Understood? So if I ask you what is the net acceleration, what is the angle made by net acceleration, that also we can find out. Understood? Na? Something like this, isn't it? So this is going to represent what? The net acceleration. Clear? So please tell me, do you understand the difference between uniform and non-uniform circular motion? आप आराम से बैठो यहाँ पर, ठीक है? आराम से बैठो. Okay. Do you understand the difference between uniform and non-uniform circular motion? So in a uniform circular motion, speed is constant. That's why there is no tangential acceleration. And in a non-uniform circular motion, speed is variable. So we have tangential as well as centripetal, both type of acceleration in the non-uniform circular motion. Okay. Actually, let's discuss one example. Okay. In this example, what is given to us? Velocity of a particle given to us. Okay. Tangential velocity. Okay. Velocity of a particle is given something. Let's take it k r t. It is given to us. Okay. Velocity of particle is how much given to us? K r t. And particle is doing what? Can you tell me what kind of circular motion is this? Uniform or non-uniform? Tell me. By looking at the velocity expression, can you answer that? It's a uniform or non-uniform circular motion? So you see that velocity is depending on the time. And as time will change, then the velocity will change. The particle is doing what? It is doing non-uniform circular motion. Okay. Particle is doing non-uniform circular motion of what? Of radius r. Okay. Find first thing, what is the tangential acceleration? Second thing, centripetal acceleration. Third thing, net acceleration. And fourth thing, angle made by net acceleration with tangent. Okay. Angle made by net acceleration with tangent to the path. With tangent to the path, how much angle it is making. Okay. And all these things calculated at t equal to 2 seconds. Everything at what time we are going to calculate? Find all these four things at what time? T equal to 2 seconds. Okay. So please tell me how much is this coming. Okay. Okay. Are you trying this one? Tell me. Velocity
Yes, sir.
expression. How do you calculate the tangential acceleration? How do we calculate the tangential acceleration?
Okay.
Tell me, how are you going to calculate the tangential acceleration? Tell me. Tell me, how are you going to calculate the tangential acceleration? First of all, let's calculate the tangential acceleration. So how did you calculate it? Calculated. So how did we get the tangential acceleration? Tell me. So tangential acceleration means what? dv by dt. Okay now. So d by dt of what is the velocity given in the question? K is a constant here. R and C. So if you differentiate it, k and r is a constant, and dt by dt 1 it will become. So tangential acceleration we have it as k into r. Now the next thing they ask in the question is the centripetal acceleration. Centripetal acceleration is what? V square by r. What is the v we have? krt square by r. We are getting k square r square t square by r we are getting. Okay, so if we simplify it, the centripetal acceleration is coming k square r t square. Understand? The second thing is the tangential acceleration, centripetal acceleration. Net acceleration, if they ask you in the question, what it will come? Under root of tangential acceleration squared plus this square, isn't it? Now you can simplify it, isn't it? K squared outside will come, r square outside it will come, and if you take it outside, then it will come as the square root. Na? So kr will be coming outside. It will become 1 plus k to the power 4 is there. Na? K square taken common. So k square still will be there. R outside, isn't it? And t to the power 4 is there. So this is what the net acceleration we have. Understood? Please tell me. And all these values they ask at t equal to 2 seconds. So tangential acceleration, so it is coming independent of t. So its value will be always k into r. But centripetal acceleration is changing with time. So t equal to 2 they are asking. So we should put it there, t equal to 2 in the equation. Okay. Now, last thing they ask in the question, angle made by net acceleration with the tangent to the path. So to do that, you need to draw the exact path and then try to see what is happening here in the question. Here, if you see, if I look at the path, can I say that this is the tangential velocity? So this is what the tangential acceleration we have. This is what centripetal acceleration we have. And this is what the net acceleration. And the question asks what? The question asks what is the angle between tangential acceleration and net acceleration. So does that mean they are asking what is this alpha angle? Now, if you look at this diagram, you see that the tan alpha can be written as a centripetal by a tangential. And we have calculated both of them, centripetal as k square r t square and tangential as k into r. So what are we getting? kt square. That is the value of tan alpha we are getting. So please tell me, understand this question? So this question was about what? About if a particle is doing the circular motion, what are the different type of acceleration it is going to have? Sometime it may only have tangential acceleration. Sorry, sometime it may only have the centripetal acceleration, and sometime both centripetal as well as tangential. Is it possible it has only tangential acceleration? No. Without centripetal acceleration, any particle can never do the circular motion. Understood? Without centripetal acceleration, a particle can never do the circular motion. Understood? So to do the circular motion, centripetal acceleration is what must. Okay? And how much is the centripetal acceleration? V square by r or omega square r. So now the question arises that centripetal acceleration, if a particle is having, that means there must be some force who will be creating the centripetal acceleration. Please tell me. Without force, can we have the acceleration? Please tell me, is it possible to achieve the acceleration without force? Tell me, is it possible? that there is no force, but we got the centripetal, we got the acceleration of a particle. Not possible, na? So to get the acceleration, we definitely need to have what? The force acting on it, isn't it? So who will provide that centripetal force? So centripetal force can be provided by any of the known forces. Known forces means what? Till now, how many forces you have seen? Gravitation, tension, normal, friction, spring, isn't it? It's electrostatic force, right? In the last class of electrostatics, you have seen it. Electrostatic force was providing the centripetal force towards center, isn't it? So any one of these forces can provide the centripetal force. Maybe one of them, maybe two of them, maybe three of them, maybe the combination of these forces, isn't it? So now we are going to uh, take some examples where we are going to calculate these forces. Okay. So centripetal acceleration is how much? Tell me, how much is the centripetal acceleration? So centripetal acceleration, that is the most important part of your circular motion. Okay. Centripetal acceleration, if I ask it, you can say that it's going to be v square by r, or you can say that it's going to be omega square r, right? So if I ask you what is the centripetal force, so will you write it mass into centripetal acceleration? So mv square by r or m omega square r. So now I am going to discuss few of the example where we will learn that how these forces are responsible for someone doing the circular motion. Is that clear? Please tell me, clear this one? So now I'm going to discuss around 5 to 7 examples on that. Okay, different cases where the different type of force is giving us the force towards the center. Okay, a very simple case I am taking. Let's say a particle is there. It is connected with a string. Okay, and it's rotating in the circular horizontal plane. Keep in mind this, which plane it is rotating. This particle is rotating in which plane? This particle of mass m is rotating in the horizontal plane. Okay, and the length of the string is how much? Let's say 2 meter is given as the length of the string. Okay, and mass of this object is also given as 5 kg, and it's rotating with what? Angular velocity of 2 radian per second. So now the question they are asking, find the tension in the string. Find the tension in the string. Can you tell me in this object, in this situation, who is providing the force towards center, or who is acting like the centripetal force? Can you tell me which force is acting like a centripetal force here? Is it the tension acting like a centripetal force? Because if you look at the tension, is the tension is going to pass through what? Isn't it? This is where the center of the circle is there, and in this circular path, this particle is rotating. So here, tension is the force acting towards center, or you can say net force acting towards center. What is that? T, tension. So here, in this question, what is happening? Actually, the tension is acting like what? The centripetal force or force towards center. How much that should be? Can I use it here? M omega square r. Mass is 5 kg, omega is 2 square, and radius is 2 meter. So 4 into 2, 8 into 5, 40 Newton is the tension in the string. Sometime tension in the string is given, or sometime they will give you the maximum tension in the string is this much. Tell me how much will be the omega with which I can rotate the particle. Understood? Means if maximum tension can be this much only, then tension in the string should not exceed that value. Understood? So with that we will calculate it. So there is no fixed kind of uh, centripetal force. Centripetal force can be the combination of tension, normal, spring force, friction force. Okay, like that. Please tell me, clear this one? Let's take an example here. A curved road is like this, okay? Like this and like this. Understand? Three section of the road is there. One case it is the hill, second case it is the valley, and third case the road is what? In the flat situation, okay? Clear? And a vehicle is there. This vehicle is moving with constant velocity of 5 meter per second. Okay, and the weight of or the mass of this vehicle is what? Mass of the vehicle is 100 kg given to us in the question. Okay, clear? Now they are asking in the question. Okay, I have given the velocity. I need to just check it. Okay. Uh, 25 by 5. Okay, chalo. Let's take it. Now here what will happen? Can I say here the center will be lying somewhere here? Please tell me. Now center is here. So radius is given here as what? Uh, 5 meter. Same thing when the particle reaches the other place. Can I say second time? Can I say the center of this curvature will be lying somewhere here this side? Understood? And third case, can you tell me where is the center lying? If it is a flat one, downward or upward? If it is a flat surface, you can take it anywhere. Why? You know why? Because a flat surface has what radius of curvature? Infinity. So that's why it does not matter that what is the where you are taking the center. Understood? Now in the question they are asking, what is the normal acting on this vehicle when it is at 3 points? What are the 3 points? Point A, point B, and point C. Understood? Please tell me, do you understand the question? And it is moving with constant velocity of 5 meters per second. Okay. Find normal acting on the vehicle, acting on the vehicle at which point? At point A, B, and C. Okay. So what is the normal force acting on the vehicle at point A, B, and C? Can you tell me which point the normal will be maximum? A, B, or C? Please tell me. Which point the normal is going to be maximum value? A, B, or C? Can you answer? It's going to be B. Whenever we are going towards uh, a valley, what happened? The direction of acceleration is in such a way that we experience more normal. Okay, and on the top part, when you are on the peak, right, you will experience the least normal. That's why there is a maximum chance of uh, lifting or jumping off this vehicle at this point. If you increase this velocity na very high, you will see it will leave the surface, it will leave that contact and just jump off this one. Understood? You can calculate it also, that what is the velocity required to jump off the surface. Okay, see, let's draw the free body diagram at point A. If I draw the free body diagram at point A, can you tell me what forces I will see it on the body? Will I say one force as 100 Z? Please tell me. Do you understand? Next, is there going to be one force, the normal, and does it have the velocity 5 meter per second? And at point A, is it moving in a curved path? It's a part of circle only, na? Point A is part of what? Any circular path only. So where is the center? Is the center is somewhere here? So tell me, out of mg and normal, which force is acting towards center? And how much is the net force towards center? Both of that you answer me. Please answer that. What is the which force is acting towards the center? That is the first thing you have to answer. There are two forces acting on the body. One is mg, one is the normal. So which force is acting towards center and what is net force acting towards center? So can I say that out of these two forces, mg is acting towards center and na is acting away from the center? So if I calculate net force towards center, will I write it 100g minus na? Tell me, 100g is towards center, na is away from the center. The net force towards center, how much it will come? 100g minus na. And should that be equal to m v square by radius of curvature? Please tell me. Poliye, tell me, do you understand this one? So what is the normal at A coming? Just check it. 100 into 10 minus 100 into 5. So am I getting 100 common into 5, or can we say that at point A the normal is how much? Normal is 500 Newton. Please tell me. If I keep on increasing this velocity, will there be a time when it will leave the contact? It will leave the contact? Tell me. So to leave the contact, what should happen? Let's learn it here itself. Okay, now. Do you understand? I gave you some particular velocity. Then you have calculated the normal for me, isn't it? But sometime in the question they will ask you, what is the minimum velocity needed to leave the contact? Now tell me, if I want to leave the contact here, what should happen? Can I write it mg minus na should be equal to mv square by r? So normal at A will become mg. Contact means what? To leave the contact means the normal is going to become 0. So if I equate it to 0, am I getting v equal to under root r into z? So if velocity of this vehicle exceed this value, understand root rg value. If it exceeds this rg root rg value, then what will happen? It will leave the contact. It will jump off the surface. Understood? Please tell me. And it's only going to leave the contact at point A, not at point B. You will see from the calculation that it's not possible to leave the contact at the point B. Understood? Can you tell me why it is not possible to leave the contact at point B? See, at B, if I draw the free body diagram, what I will see? I will see mg acting downward. Next, I will see normal acting upward, right? And this time, the center is what? The center is here. At point B, what happened? At point B, center is what? Center is upward, isn't it? At point B, what we have? At point B, we have the center as what? Upward. So this time, what will happen? Which force will be towards center? So NB will be towards the center, MG will be away from the center. So NB minus MG is the net force towards center. And that should be equal to MB square by radius at B. So normal at B is coming how much? M more velocity with which you will try to go into a valley, the more normal you will feel it on the vehicle. Understood? Now mg is what? 100 into 10 plus mass is 100, velocity is 5 square, radius at B is also given to us. All these value we are going to put it. We are getting 1500 Newton force. And at C, if I try to calculate, what is the answer will come? So at C, there is no curvature. Na? At C, radius of curvature is how much? At point C, the radius of curvature is infinity because a flat surface will not have any curvature. Understood? So C point, what will happen? Normal like this and mg like this, and radius of curvature is infinity. Although it has velocity here, but when you will write the equation, you will write it nc minus mg equal to mv square by infinity. You will say, sir, why did you consider the center towards normal side? We could have taken it from the towards the mg side. Yes, but you see, na, it is still what written mv square by infinity. So whether you write it nc minus mg equal to mb square by infinity or mg minus nc equal to mb square by infinity, this term is again going to become 0. So what is the normal at C we are getting? Mg we are getting. That means 1000 Newton we are getting. So that's why what is the normal at A? 500, B 1500, C 1000. Understood? So whenever you get a question where you have to find out what is the force acting or what is the force required or velocity needed to leave the contact means always same thing. Whenever an object is going to leave any kind of contact, the normal force will become zero. String is getting slack. That means tension is becoming zero. Understood? String is broken. That means tension is what? Has become zero. So please tell me, understand this question. And there is no fixed type of centripetal force. Centripetal force can be anything. It can be a normal, it can be a tension. Okay. Like first example you have seen where the normal was acting like centripetal force. First example, tension. Second example, normal. Let's take another example and try to understand the same thing. Okay. In this example, what is given to us? आप आराम से बैठिए ना, बैठिए आराम से आप एक जगह पर बैठ जाइए, ठीक है? Now, in the third example, we are going to take what we are going to do it. Let's say here in the question, what is given? A horizontal surface is there, okay? And a spring constant is K, mass M is hanged with that. And now I am going to rotate this spring with angular velocity omega. Initially, this L is what? Initially, L is the natural length of spring. Okay. L is what? Natural length of spring. Understood? Natural length of spring means what? That no elongation, no compression in the spring. Okay. So now if I rotate it with some angular velocity, so normal and mg to vertical plane, that is sorry, vertical direction, that's already balanced. So about this point is going to act like a center here. So please tell me, the question asks if k is the spring constant and it's rotated with angular velocity omega, the question is asking find the elongation in the spring. Find the elongation in the spring. Understood? To move it in the which plane? Horizontal plane. I'm just writing only half of the statement, not the entire detailed statement, but I'm telling you that it's a horizontal plane kept like this. And now it is being rotated with angular velocity to move in what plane? Horizontal plane. So there is no chance of uh, this normal NMG to do anything. So it will do the circular motion only because of what force? Only because of the spring force. Okay. So please tell me how much is that coming? Okay. So please tell me how much is this coming? Will you try this one? Initially not rotating, so initially, please allow mat itna. Okay. So initially the spring will be in the natural length, means no elongation, no compression, isn't it? But when you rotate it, what will happen? It will need a spring force to allow it to do the circular motion, isn't it? So please tell me how much is the elongation coming in the spring? Trying this question? Please tell me. So tell me, have you done this one? How much is that coming? Tell me. So here you see, right now L is the length of a spring, isn't it? And if a spring stays in the natural length, then it's not going to have any kind of what? The spring force, okay? So what actually will happen when it will try when it will try to when it will start doing the circular motion, what will happen? This spring will be elongated by something x. So now the length of this spring will become what? Something L plus x. Out of L plus x, L is the natural length and x is the elongation in the spring. Understood? So if spring got elongated by x, what does it mean? What is the force acting towards center? Is the force acting towards center is kx, and kx must be equal to what? M omega square r, because question give me the omega. So that's why I'm using what? M omega square r to solve my question. And can you tell me what is the radius of the circular path? It's L plus x. Understood? What is the radius of the circular path? That is L plus x. Now if you simplify it, you are getting x common, k minus m omega square equal to m omega square L. So what is the x we are getting? M omega square L divided by k minus m omega square. So that is the elongation in the spring. If they are, what is the spring force? So kx we can answer. Understood? But we can answer kx as my answer. We can make it. Understood? So that is the spring force. So now you see in this question what happened? The spring force is acting like what? The force towards center. Another question you will see that I'm just giving you an example so that you will understand what is a centripetal force. Centripetal force is not a kind of force which we can draw it in the free body diagram. It's just a force which can be anything in the nature. Like let's say if a disk is there, okay? A table is there. Table is rotating with what? Angular velocity omega. Okay. And what we did here, some distance from the disk, we kept a coin. Okay. Mass of the coin is what? Mass of this coin is m, and this coin is kept some r distance from the uh, this disk axis. Okay. Circular disk is there. From that axis, r distance away, this coin is kept. In this question, there are three things can be asked in this question. Sometime what will happen? R is given in the question, omega is given in the question. They will ask you, tell me if this coin is a smooth one. Sorry, if this disk is a smooth one, can it do the circular motion? Can it stay on the disk if it is a smooth one? No, it will just thrown out of the disk. Understood? But if we have a sufficient amount of friction present there, then what will happen? It will continue to do what? The circular motion with the same angular velocity as the disk. Same thing you will see. Initially, the disk will stay, sorry, coin will stay on the disk for some omega. But if you keep on increasing the omega, after a certain value, do you see the coin will be again thrown out of. So all these things can be asked, and all these things can be answered by a simple thing, the free body diagram. If I draw the free body diagram of this coin, can you say the normal will be acting upward, mg will be acting downward, and can you tell me which force is acting on the coin towards the center? Is that the static friction? Please tell me. So here, what do you see? Here you are seeing that the friction is responsible for its circular motion. Understood? Which force is providing the necessary force towards center in this question? The friction force. Understood? Please tell me. So if you write the equation, what is the equation you will get it? Normal equal to mg. Second thing. Second thing we will write. Second thing we will write is Fs equal to mass of the coin omega square into r. Depending on the question, what did they ask? Let's say in the question, mass is given, radius is given. They ask what is the minimum coefficient of friction. Okay. You see, these two are the most important equation of this question. Okay. Anything else which has been asked in this question can be only solved using these two equations. But it depends in the question what is given and what they are asking. Like I'm giving you the mass and I gave you also that where the coin is placed. I want to know what is the coefficient of friction needed. So for minimum coefficient of friction, for minimum coefficient of friction requirement. Okay, for minimum coefficient of friction requirement, what will happen? Whatever the Fs I have calculated now, I will convert it into Fs max. So mu minimum, and what is the normal we have? Mg equal to m omega square r. M and m get cancelled out. So what is the minimum coefficient of friction needed? Omega square r by c. Understood? So in the question, what did I give to you? I gave to you the omega value. I also gave that from the axis of disk, what distance away it is doing the circular motion. And then I asked, what is the minimum coefficient of friction needed to do the circular motion? Second type of question here, it will be asked that what is the maximum omega, photo ऐसे रखो ना आप. What is the maximum omega for which coin can coin can stay on the disk. That is another way the question can be asked. Can stay on the disk. Of this time I gave you the mu. Okay, now understood. In this question, what happened? The mu is given to us. So more the omega, more the requirement of friction, isn't it? Check it, because the friction is only providing the m omega square r. If I increase the omega, isn't it? I need more friction. So maximum omega means maximum friction. Maximum friction means what? Mu into normal, and m, can I write it here? Omega max square into r. Again, m get cancel out. What is the maximum omega we got it now? So maximum omega we got it mu g by r under root. Matlab, this is the maximum value of omega for which the coin can stay. In this question, what happened? Mu is given, r is given. Now you have to calculate omega max. First question, omega given, r given, you have to calculate the coefficient of friction. And there is a third set of the question. In the third set of the question, they will ask for maximum r. See, the more you will be away from the center of the disk or the table, the more force you will need to move on the table, to move with the table. Understood? For maximum r, for which this it can stay, or coin can stay on the table. Okay, na? It can stay on the table or on the disk if they are asking in the question. What I should do it? Again, maximum r, maximum friction. Maximum friction, mu into normal. Normal is mg. M omega square r max. Mass, it is coming always independent, okay? So what is the maximum radius at which it can stay? It's a mu g by, it's a mu z by omega square. Understood? It is what? It is mu z by omega square. Understood this question? Please tell me. So you see here, what is the force which is responsible for doing the circular motion? Which force is acting like the centripetal force in this example we have taken? So in this example, the friction, yeah, you know. In this example, friction force is acting like what? Friction force is acting like the centripetal force. Okay. So you see, in this example, you see the friction force is acting like the centripetal force. So there is no fixed set of friction centripetal force. Okay, it depends on the situation given to us, that a different type of force can act like a centripetal force. Okay, last example here, let's find out what is the orbital velocity of the satellites. In the satellite motion, what will happen? A planet is there whose mass m and radius r is there, and a satellite is doing what? A satellite is doing the circular motion about this circular orbit of radius r. Now tell me, if I see again, it will have some velocity v naught. Who will be applying that? Who will be applying the force now on this one? So will you see the force which will be acting on this one is going to be what? The gravitational force, isn't it? The planet will be applying the gravitational force on the satellite. Let's say the mass of the satellite is something m. So how much it will come? G m1 m2 by, what next will come? G m1 m2 by r square will come. That we can write it m v naught square by r. One of the m and one of the r will get cancel out. What is the orbital velocity we are getting? Gm by Gm by small r it is coming. So if we got the orbital velocity, can we also calculate the time period of this circular motion? Please tell me. Can we also calculate what will be the time period of the circular motion or orbital motion? Time period will come 2 pi r by orbital velocity. So you see that how much is that coming? If you are calculating, is it coming 2 pi by root gm r to the power 3 by 2 it is coming. So you see t squared is coming what proportional to r cube, and that is nothing but the Kepler's third law as well. Okay, so here we have again seen that this particle is doing again a circular motion. These satellites are doing what? The circular motion only, but the force which is responsible for allowing a particle to do the circular motion can be any one of the real forces. Real forces means what? It can be normal, it can be tension, it can be gravity, it can be friction. So these are called the real forces. Okay, so it can be any one of the real forces which can provide the necessary what? The centripetal force, you can say that. So please tell me, understood what we discussed till now? Please tell
Yes,
me,
sir.
all of you.
Yes, sir.
Tell me, Charan, Manal, Lokesh,
Yes,
understood?
sir.
Yes, sir.
Right. So please, mat kariye. Okay. So next we will continue it on the Thursday. Okay. Tomorrow I have to go outside. Okay. So next we'll continue on the Thursday then. Okay. Right.
Yes, sir. Thank you.